forward to having us present to you the modern data state, things you can now do in analytics in the Azure cloud that were quite challenging in the past. So with that, I'm going to hand over the presentation for the first hour to Spencer Cook. Spencer is one of our leading data scientists. He also does significant data engineering for the data science to be useful and valid. And he's going to take us through the overview of Synapse Analytics. And after that, I'll be walking you through the lab process if you'd like to go through that. There are some hands-on labs after the slides. So with that, no reason to delay. Spencer.
Great, thanks, Sean. Yeah, like Sean said, Spencer Cook, Senior Data Scientist at Valorem Reply. I'm going to be walking you through this Analytics in a Day workshop. The goal of this presentation is to show you how analytics can transform your business, and more importantly, what concepts you must understand to do more with data. So let's dive in. So you're going to see 5 sections here. We'll go through them in order, so you know, no need to spoil them now. And then, like Sean said, we're going to go through a where is that? We're going to go through a section of labs after my portion. You'll have a hands-on lab using Azure Synapse Studio and Azure Databricks. So let's go ahead and jump into section 1. So data warehouse is a fundamental concept for getting the most out of your data, right? So let's talk about whether or not it's still relevant in today's day and age with everything going on with Synapse, Databricks, etc. So in the world of technology, everything moves pretty fast. New products come to market at alarming speeds, and there are more and more sophisticated ways to capture and manage that ever-increasing amount and variety of data. So you might think it's surprising to hear that data warehouses are still as relevant as they are when they were originated 30 years ago. But it's true. The only case because the data warehouse has modernized over time and is a distant relative of the data warehouse architecture from 1988. So it's the case, you know, mostly in name only, kind of a semantic thing, but the concepts are still incredibly relevant. So let's first talk about how the world of data has changed. So now all businesses are data businesses. So anything from the corner store with its online accounting and stock keeping to large internet retailers, we all run on data. An enterprise that does not manage, govern, and secure its data will not survive in this new economy. It becomes one thing to gather and manage data, but it's another thing entirely to make decisions based off of it. That's where analytics comes in. So without analytics, data doesn't serve any role. Dashboards and reports support awareness of the state of the business. BI and visualization strengthen the role of knowledge workers with informed insight. And augmented intelligence can discover information and patterns that even experts may overlook. Analytics are important, but it's increasingly evident that not all analytics are equal. Businesses can do more and more complex analysis for better, faster, and more automated insights. Data science enables automated insight with a depth and scale beyond the abilities of human analysts. Even small businesses today need scalable analytics of social media, digital interactions, and markets. And increasingly, machine learning and artificial intelligence drive autonomous processes and decisions for smart organizations. So let's look at how a data warehouse serves a business through this simple architectural diagram. Note, the modern data warehouse sits at the heart of enterprise analytics. It's a source of sanctioned data, a system of record, and a hub serving up models for reporting, business intelligence, and data science. Let's start on the left. We have an enterprise system of record for business processes, since the data warehouse is mostly built over a line of business data sources. And whether that data is unstructured, structured, or semi-structured, the modern data warehouse can handle it. Other more volatile sources are often used for data science or for ad hoc analysis. For the data warehouse, Azure Data Factory schedules and orchestrates data transformations and bulk loads. Meanwhile, Azure Databricks performs transformations specifically for data science and also builds and executes models. Scores from these models may be loaded into the data warehouse to integrate these insights with enterprise applications and reports. Forgot to advance my slides. So we see Azure Databricks here doing our bulk loads and transformations for data science. Meanwhile, Azure Data Lake can be used to store raw data in high volume for later use, along with staging transformed data from Azure Databricks. And then Azure Synapse Analytics provides high performance, highly scalable data storage for enterprise models with outstanding security, governance, and manageability. And then finally, Power BI consumes your sanctioned enterprise data from the data warehouse for reporting and analytics, but may also use data from the data lake for ad hoc analysis and integration with data science. Many business services, including line of business applications, consume data from the data warehouse as an authoritative, governed source of enterprise knowledge. So Microsoft has brought a new end-to-end analytics platform that brings together all those pieces. Your data ingestion, big data, and data warehousing into a single unified service. And that's what Azure Synapse Analytics is. So not only are these critical parts now fully integrated and managed, but there's also a deep native integration with Azure Machine Learning and Power BI. Finally, there's an end-to-end analytics platform that brings the critical functions of a data warehouse to be in the same environment as other data tasks. So that's the end of section 1. Does anyone have questions so far? Okay, great. So let's go ahead and look at how data warehouses and data lakes work together. And how they facilitate the different worlds of data science and business analytics. Increasingly, analytics and AI have become a hot topic for businesses, but truly unleashing the potential of data with these technologies has proven challenging to leadership. Many businesses report deriving deep insights from data. Half of those who reported difficulties also described disparate data sources preventing a holistic view. So if you're having these troubles, you're not alone. The approach to data lakes and data warehouses differ in a couple of key areas. Data lakes tend to lend themselves to massive semi-structured sets of data that allow for fast exploration and experimentation, but this is not without its downsides. The clean data nature of a data warehouse provides greater security, privacy, and dependable performance with structured and relational data. However, both of these systems have important business value. To truly capitalize on data, businesses must be able to invest in both distinct approaches. Can everyone make sure that you're muted if you're not speaking? Security is paramount to business in our modern world. All businesses should have access to enterprise-grade security features, and more recently are mandated to have these robust measures in place. Meeting these requirements without an intelligent solution can create a significant management challenge. Allowing for open data exploration and experimentation while remaining stable, performant, and most of all secure is really challenging when you don't have a clear view of all the data in play. Controlling access to data in the first place can prevent its own challenges, let alone providing trusted users a streamlined authentication process. Providing a quick and dependable service to users is tricky as well. Some requests are intensive yet predictable, whereas others are unscheduled and unique. And on top of this, high priority service for C-suite stakeholders, etc., must be ever available. Flexing more muscle, especially in the cloud, is a solution to manage diverse workloads, but it's not without drawbacks, namely cost. And even beyond cost, bringing up these extra resources takes time and operating overhead. And finally, interacting with different formats can be cumbersome. Data scientists need the ability to query varied types of data with as little special handling as possible. Additionally, developers need to set version control, consistent integration, and deployment, and the ability to perform various testing scenarios. Azure Synapse Analytics brings together solutions that address both approaches of data lakes and data warehouses in a service that provides limitless analytics. It's quick and easy to configure, allows for fast exploration while ensuring enterprise-level security and privacy with the performance necessary to meet any scale of demand. So before we move on to section 3 about BI and data warehouses, any questions so far? Okay, great. So let's go ahead and move into BI and data warehouses. So we've talked about key elements from a modern data warehouse. Now let's dive into why it's important for business intelligence and what do you need to know to derive intelligence from data. Understanding your data is only one piece of the puzzle in today's modern world. Being able to articulate your data's insights to your organization is where real value is found. Increasingly, decision makers reach beyond traditional reports and dashboards to engage with new sources and tools like big data, machine learning, and even AI. In this environment, being able to define and work with data-driven processes is essential. Data literacy has become more than just an individual skill, it's a shared organizational practice. When shared data literacy can be combined with self-service tools, individuals become empowered, teams become tighter, and organizations become stronger. Business users today are tech smart, and they expect tools and services that work the way that they do. Just like bring your own device, users expect to use self-service analytics tools to build their own dashboards and visualizations. And in an enterprise with self-service analytics, IT cannot expect to control or constrain every aspect of knowledge work, but they can provision data and services while monitoring their usage and security. Self-service business intelligence puts data governance in the hands of all users. IT's new role is to provide well-managed tools and services to support effective best practices, even if they cannot guarantee the results. Services include curated data for business users to consume BI and analytics. Platforms include data warehouses and data lakes with data science tools and self-service analytics. New business capabilities are not enabled by data alone, but by data models that describe concepts, relationships, rules, and standards. Enterprise models consolidate data from many systems and act as a centralized source for analysis. Business intelligence models use enterprise models but focus on a single subject area in more detail. And ML models are developed from raw sources and are often experimental and require specialty skills for production use. So we'll revisit these different data models and we'll talk through why they still matter if businesses are tech smart and data literate. So for consistency, there are numerous business processes that should be built once and shared as a corporate standard, such as dividing data catalogs, staff hierarchies, and client org IDs. For governance, certain data sets such as customer information or financials need security and privacy controls, which may be complex and dynamic. And for efficiency, we want models that already exist in the data warehouse and there's no need to repeat the work of design, preparing and loading data, or securing the model. We also want flexibility. There are numerous data sets that are temporary, external, or ad hoc. They're unlikely to be consolidated into the data warehouse. In these cases, business intelligence models are useful. For example, planning and monitoring a short-term campaign, or modeling a budget for a departmental project. For the sake of efficiency, tech-smart business users have a fresh and innovative ideas that they need to explore with agility. The process of building centralized models to support all these initiatives is too cumbersome, but successful and widely adopted business intelligence models may be refactored into the data warehouse for future enterprise use. So if you sort of look at that structure, you can see how Synapse Analytics and Databricks together can both facilitate data science results and enterprise models all in one structure that can then facilitate reporting from something like Power BI. Okay, so before we move into the cloud for modern analytics, any questions about what we've covered thus far? I see we've had a couple people join. Okay. So we've talked about the key elements to a modern data warehouse. Why should it be in the cloud? What are the advantages? So the cloud enables projects that are easier to start and easier to scale. ERP, CRM, and operational applications are increasingly cloud native. And collaboration platforms and file sharing have been transformed by cloud's flexibility and scale. Even when governance requires on-prem data management, modern businesses tend to be hybrid. I personally can't imagine going back to anything non-cloud based after going cloud native for the last few years. Cloud-based data warehouse services provide layers of protection and built-in security along with compliance tools. In the data warehouse itself, you can expect encryption, sensitive data classification, and row and column-based security. But you also need services such as threat detection and monitoring, virtual networks, and integrated ID management. Resilience and availability are not just objectives, but become vital security features for global always-on services. Geo-replication, point-in-time restore, and highest availability all come with the cloud. Again, something I couldn't even dream of trying to manage myself. Can everyone make sure you're muted again? Thank you. Cloud-based data warehouses eliminate the need for large CapEx investments. Deploying your data warehouse in the cloud is faster, easier, and more flexible than a traditional data solution without the high hardware and infrastructure costs. Iterating designs and handling diverse data is far more efficient than for an on-prem solution. World-class performance is available to all users as Azure Synapse Analytics optimizes analytical and operational workloads with elastic scaling. As the volume and variety of data continually expands, modern cloud-based data warehouses can serve as the home for all data. Enterprise models, BI sandboxes, and predictions can all be stored, managed, and provisioned together. Enterprise ETL or self-service data wrangling are both handled efficiently with no need to juggle processing schedules. Deliver enterprise reports and enable ad hoc discovery with an endless variety of visualization or data science tools. Power BI is the leading market platform that offers incredibly robust capabilities on Azure Synapse Analytics, which is the highest performance cloud DW. You can kind of see where we're going. DW query performance is no longer just a matter for IT. Today's leading tools like Power BI can analyze and visualize large volumes of data. Self-service users' queries are often exploratory and ad hoc, not scheduled. Power BI users wishing to analyze real-time or unstructured data thus need a scalable platform that can be queried easily that has familiar syntax and connectivity. Azure Synapse Analytics delivers insights from all of your data across data warehouses and big data analytical systems, all with blazing speed. Data professionals can query both relational and non-relational data at petabyte scale using the familiar SQL language. And for mission-critical workloads, they can then easily optimize the performance of all queries with intelligent workload management, workload isolation, and limitless concurrency. And then Azure Machine Learning comes in and augments these analytics capabilities and business insights with a quick build out and deployment. Empowering developers and data scientists with a wide range of productive experiences for building, training, and deploying machine learning models faster. This accelerates time to market and fosters team collaboration with industry-leading MLOps tools, or DevOps for machine learning. So before we wrap up the overview, any questions about section 4 or any of the previous sections? See, we keep having some people trickle in, so I want to make sure everyone's up to speed. Okay, great. So let's wrap up this section with some parting thoughts. So Azure Synapse Analytics brings together multiple sources of data: unstructured, semi-structured, and structured data from on-prem, the cloud, and SaaS, line of business, IoT. It allows integration, management, and monitoring of all these data sets under a unified experience using familiar systems like SQL, Apache, Spark. Natural connections with Power BI and Azure Machine Learning empower business users to make more informed decisions at a much faster pace. This brings data teams together and enables them to seamlessly and securely collaborate, share, and analyze data. As data integration, data warehousing, and big data analytics can all be done in a single pane of glass, businesses can break down organizational silos that stagnate the time to insight. You can manage, secure, and analyze all types of data. That makes it easier to make decisions at a faster pace. Managing and securing and analyzing all these types of data on a single service can also provide structured or semi-structured data for data engineers and data scientists. This enables your data professionals to build end-to-end analytics pipelines without ever having to stitch a multitude of services together. It's an all-in-one go-to place. By bringing the existing skills across your business together to accomplish more with your data, with the deeply integrated Apache, Spark, and SQL engines in Azure Synapse, data professionals who prefer the familiar SQL language can seamlessly collaborate with those who prefer Spark and vice versa. So for instance, those who prefer SQL can query Spark tables using transactional SQL. And data engineers or data scientists who prefer languages such as Python, Scala, Spark SQL, or C# can transform data, train models, and create proof of concepts in the same service that houses those data pipelines, data lakes, and data warehouses. So from what we've seen so far, it's clearly a mistake to think that new technologies such as big data, self-service BI, and data science have somehow superseded established technologies such as the data warehouse. When in fact, Microsoft's Azure Synapse Analytics, a modern data warehouse with advanced architecture, security, and manageability, is more relevant than it's ever been. This is especially true when provisioning data for self-service, as regulations worldwide demand greater governance, even while businesses demand greater autonomy. So let's go ahead and dig into the specifics around how Azure Synapse works. But first, I want to query the room, and you can either raise your hand or say so in chat or even unmute your mic. Who here has used the Azure Data Warehouse, Azure SQL Data Warehouse previously? Anybody? So if you've used Azure SQL Data Warehouse previously, you're already a Synapse customer. Everything has just moved over seamlessly. Really, Synapse is just taking the existing tried and true Azure SQL Data Warehouse and enhancing it, adding Spark and a couple other quality of life, more data lake focused features. And so that really makes it an exciting project to get in early on, because it's a tried and true solution that's just getting better month by month. Azure Synapse Analytics is a limitless analytics service with unmatched time to insight that delivers insights from all your data across data warehouses and big data analytics systems with blazing speed. It truly enables next level analytics. And like I said, Azure Synapse is a SQL data warehouse evolved. We have taken the same industry-leading data warehouse and elevated it to a whole new level of performance and capabilities, backed by the cloud platform that you trust and industry-leading compliance. Not only is Azure Synapse Analytics able to provide petabyte scale analytics with quick time to insight, it does so with the best price performance ratio in the industry. Azure Synapse Analytics is 14 times faster than other cloud providers, exceeding Amazon Redshift, Snowflake, and Google BigQuery. So let's look real quick at some customers who have taken advantage of Azure Analytics and reaped the benefits. Each of these stories highlights a unique benefit that was realized. ABI's case highlights the performance enhancements they experienced. Newell noticed significant cost savings. And Walgreens used insights on data to best manage their inventory while remaining scalable. All the customers we just mentioned used cloud scale analytics to achieve their goals. We have customers who leveraged the modern data warehouse to track and ingest and analyze varied data sources, as well as customers performing fraud detection analysis. As we talk through these use cases for Microsoft customers, notice that at the core of all these examples is Azure Synapse Analytics.
Yeah. Spencer, sorry to disturb.
Yeah.
It looks like some of the sentence what you were saying, the last got missed somehow. We couldn't hear it.
Okay. Yeah. Let me walk back. So I was just talking about how across all these different customers, they're all using Azure Synapse Analytics as the core of their solution. So some of them were using it to, lower costs. Some of them were using it to enhance performance, but they're all using Azure Synapse as the core of their analytics platform for things like modern data warehousing, advanced analytics, and real-time analytics. That makes sense?
Yep.
Okay, thanks for speaking up. Yeah. And so the reason that they're all using Azure Synapse Analytics is for the reasons that we touched on before. It's because Azure Synapse Analytics brings together 3 domains of a modern data warehouse. Varied data sources can be ingested, transformed, modeled, and served all through one powerful service. So by bringing together enterprise big data warehousing and big data analytics, it gives the freedom to query data on your terms using either serverless, on-demand, or provisioned resources, all at scale. Azure Synapse brings these 2 worlds together with a unified experience to ingest, prepare, manage, and serve data for immediate BI and machine learning needs. Microsoft has taken the same industry-leading data warehouse to a whole new level of performance and capability. businesses can continue running their existing data warehouse workloads in production today on Azure Synapse and will automatically benefit from those new capabilities that are in preview. Businesses can then put their data to work much more quickly, productively, and securely by pulling together insights from all data sources, data warehouses, and big data analytics systems. So fundamentally, Azure Synapse has 4 components that we're going to walk through. You have Synapse SQL, which is complete T-SQL-based analytics. You have Apache Spark for Synapse, which deeply and seamlessly integrates Apache Spark, which is the most popular open source big data engine for data prep, data engineering, ETL, and machine learning, all on top of a simplified resource model that frees you up from having to worry about managing clusters while allowing for fast Spark startup and aggressive auto scaling. I'm especially enthusiastic about that component. The Synapse pipelines come in and use the same data integration engine and experiences as Azure Data Factory. It actually basically is Azure Data Factory just baked into Synapse. And this allows you to create rich data pipelines without using a separate orchestration engine. It even enables code-free ETL with data flow activities. And Synapse Studio is the web-native experience that ties all of this together for data engineers, allowing them to do every task needed to build a complete solution, all in one location. So let's take a deeper look at the setup of Azure Synapse. So it's designed for analytics workloads, including AI, ML, IoT, and intelligent apps at any scale. And Azure Synapse Studio makes it so that we can have a unified workspace for data prep, data management, data warehousing, big data, and AI tasks. It's a software as a service developer experience for code-free and code-first. The platform is suited for multiple languages for compatibility with different analytics workloads. You can see the list here. And then there's integrated analytics runtimes available for both provisioned data warehouses and serverless. This includes the Synapse SQL offering T-SQL for batch, streaming, and interactive processing, as well as the Synapse Spark runtime, which includes your big data processing for Scala, R, and .NET. This integrated platform enables management, security, monitoring, and a meta store. And all of this is data lake integrated and common data model aware. And because it's all on Azure, Synapse integrates with other Azure services as well as third-party applications. So to recap, components like Synapse SQL, Apache Spark for Synapse, Synapse Pipelines, and Synapse Studio all make Azure Synapse Analytics a unified end-to-end analytics solution. So before we jump into a demo of Synapse Studio, any questions about that previous set of slides?
It may be worth mentioning that the slides are slightly out of date, and Synapse came out of preview in December. So several of the features that said preview, like the Spark pools, are now GA and fully supported as production ready by Microsoft.
Yeah, that's a great call out, Sean. And with something like Synapse, similar to Power BI comes to mind, it's worth keeping up with their blog and their press releases, because this is a technology that's evolving on a week to week or month to month basis. We're not waiting for yearly releases or something like with more let's say experienced or wise tools. So let's jump into Synapse Studio. So Synapse Studio is the web native experience that ties all this together. It's the single pane of glass experience that we talked about earlier. So it brings together everything for data engineers, allowing them in one location to do all the different tasks they might want to do to build out a complete solution. Whether that's building an end-to-end analytics solution in one place with ingestion, exploration, preparation, orchestration, and visualization tasks all in the same environment, or industry-leading productivity if you want to write SQL or Spark code using notebook experience. You can author, debug, and performance optimize all in the code environment that's provided here. And you'll see some screenshots, but it's very similar to like Jupyter if you've used that, or Databricks notebooks. And then you can integrate with enterprise CI/CD processes as well for your data ops. So to get to this, in your Azure Synapse workspace in the Azure portal, you would click Launch Synapse Studio. And then you'd see these different activity hubs. All these hubs allow you to quickly access items, storage accounts, write code, supervise resources, configure your pools, or set up your pipelines. The Overview Hub allows you to quickly access common gestures, see recently used items, start coding, and view links to tutorials and documentation. Within the Overview Hub, you can also quickly begin a new SQL script, notebook, data flow, Spark job definition, Power BI report, pipeline, or import. Lots of possibilities all within that Overview Hub. If we move down the left sidebar, we find the Data Hub. After selecting the Data Hub, you can expand the storage accounts option to view the storage accounts in the workspace. After selecting a storage account, you can create new folders and upload files using the links in the right-hand window. So you might notice so far a lot of, let's say, Chrome from other tools being brought in. You know, this is exactly the same interface that you get in Azure Storage Explorer. And that's no accident. A lot of these things aren't reinventing the wheel. They're just like like a theme we've been talking about. They're just integrating different Azure services all in one unified environment so you can do your full stack data engineering or data science. If you expand the storage accounts option, you can view all the different storage accounts in the workspace. And after selecting a storage account, you can create new folders, upload files, anything you can do in Storage Explorer. And then if you select a container or file system and choose a specific file, you can even preview the data in place. There's 90 plus connectors and a logical or a pipeline-based logical grouping of activity. So it's a nice little service for sampling and viewing data off of a lake. Because it's natively integrated with your analytics platform, you aren't jumping between tools to do all this different stuff. You can also manage your fine-grained access control and configure ACLs or access control lists by right-clicking on a file or folder and selecting Manage, just like in Storage Explorer. If you right-click on, say, a Parquet, you can have it auto-generate SQL scripts or open a new notebook all from a single click. And, you know, this supports CSV too, but oftentimes, you know, like we've seen in this screenshot, it's relatively easy to preview a CSV or work with those, you know, even if you need to open an Excel. But being able to quickly read in a Parquet file, you know, I don't want to necessarily write this code every time. I am not even a huge fan of writing this more simplified Spark code to read a Parquet. So having that become just a native part of my tool set, just like you'd select, you know, top 1000 in SQL Management Studio, is really nice. And it brings together your data lakes, data warehouses, and big data analytics all in same interface. You know, you can see your SQL pools, your serverless instances, and your Spark clusters all in, you know, one heads down view. So any questions about the data exploration interface?
You'll have a chance to explore most of these firsthand as you go through the hands-on labs a bit later. So this is just a glossary and rough terms of where they are and what they do. You'll see it in person.
It's a great point, Sean. Yeah, don't fret too much about the screenshots, because you'll actually get into this environment. So the goal with the Develop Hub is to be able to start coding faster, all while using the language of your choice. So you saw that list of supported languages earlier, pretty robust. Being able to view query results with one click directly in the Develop Hub by just clicking Preview is pretty great. If you're familiar with notebook-driven development, a lot of this stuff isn't, brand new, but it's still really nice to see. It feels a lot faster and more performant than booting up, a desktop app to hit your data warehouse for sure. Plus, if you're ever stuck, I've, for instance, been in an airport or whatever, and only have, let's say, an iPad or even, God forbid, a phone. Now, all of a sudden, since you're using a SaaS app instead of a desktop app, you're able to, maybe run a query, or at least, read a query and answer a question about a KPI without needing to, be tied to a quote unquote real computer. So you can go from writing SQL scripts and back to your data flows with just one click. So if we go back to this interface, you'll see this looks a lot like what you've seen, for instance, in Azure Data Studio. But the difference is you can jump over to these data flows like you've seen in ADF, all within the same interface. You can even jump over to your Spark jobs or Power BI reports, because it's a sort of development hub, like they said. You can even bring in your Power BI workspace by adding it as a linked service. It's as simple as selecting the Power BI icon, putting in some workspace information, and now you're going all the way from your data ingestion on the left all the way to your data ingestions on the right side of our architecture slide, all within one analytics platform. And I can't think of a single thing that matches that end-to-end experience. So it's pretty exciting to see. And so let's go ahead and jump into Synapse SQL. So not only is all this stuff fast and well integrated, it's also fast and inexpensive. So GigaOM, it's a transaction performance analyzer. Basically, they're a group that benchmarks and audits different cloud platforms and puts out cost, similar to Forest or other things like that. They recently benchmarked all the top cloud data warehouse providers and found that for every unit of performance, Microsoft customers pay 75 cents and 6 cents respectively, while all of the competitors are paying at least $1. Extending the data point from the last graph, this clearly shows that Microsoft is the leader at any level of compute. They continue the leadership in the analytics space as seen in the GigaOM results published from last year. So lower is better, and this is much lower, especially compared to things like Snowflake. And because Azure Synapse deeply integrates with Power BI and Azure Machine Learning to drive insights for all users, whether it be data scientists coding with statistics, all the way up to the business user using Power BI. And to make all these analytics possible, Microsoft has announced native and built-in prediction support, as well as runtime level improvements as to how Azure Synapse handles streaming, Parquet files, and Polybase. So you can see there's now a native predict statement. And all you have to do is pass in the name of a model along with a data set, and it works natively in your T-SQL on top of the data warehouse. So it's this native integration between Azure ML and Azure Synapse, along with things like Power BI, that make this so robust. They've also enabled direct streaming ingestion support and the ability to execute analytical queries over streaming data. So capabilities such as joins across multiple streaming inputs aggregations within one or more streaming inputs, the ability to transform semi-structured data in multiple temporal windows are all supported directly in your data warehouse environment. For streaming ingestion, customers can integrate with event hubs, including event hubs for Kafka and IoT hubs. Concurrency is also a hot topic for many customers. In a nutshell, it indicates the number of simultaneous users or queries that can be run at the same time. Concurrency increased with an increase in compute power. Adding more compute power would let users access the data warehouse. Let more users access the data warehouse. There are preset functions called resource classes that users can leverage to set concurrency limits, thereby diverting resources to their most important workloads. Workload management helps you control and prioritize your workloads. Using this feature to have granular control on how your workloads are being run or how you allocate resources to different users based off the importance of their queries. Materialized views give you a new level of insight by adding transactional consistency to data modification and automatic query optimizer matching. So you can see some of the new materialized view features in the code on the left. You'll be walking through this in detail in the labs as well. When result set caching is enabled, Azure Synapse automatically caches query results in the user database for repetitive use. This allows subsequent query executions to get results directly from the persisted data cache, so recomputation is not necessary. Result set caching improves query performance and reduces compute usage. In addition, queries using cached result sets do not use any concurrency slots, and thus they don't count against existing concurrency limits. So for security, users can only access the cached results if they have the same data access permissions as the user creating the cached results. There are multiple levels of security between the user and the data warehouse. And this all is to keep your data safe and secure. While some of the competition charges for different levels of security, Microsoft does not. Microsoft offers one comprehensive security plan, all at no additional cost. So let's dive in a little bit deeper into those features and see how they keep your data safe and secure. So with threat protection, you get notified of potential threats and using auditing tools and anomalous activity alerting. You can also leverage network security to ensure that all the data is within a secure environment. Similar to, hopefully you're doing that with most of the things you provision on Azure. You can centrally manage and control identity and user access with Azure Active Directory. And you get row and column level security through granular access control. And your data is protected at rest, in transit, and in use. All at no additional cost. Azure Synapse Analytics provides fine-grained access control for your platform with a combination of native row-level security and column-level security. You can ensure that the data is secure for each user. Dynamic data masking enables administrators and data developers to control access to their company's data, allowing sensitive data to be safe and restricted. It prevents unauthorized access to private data by obscuring the data on the fly. And because your data warehouse stores your most important and valuable business data, you should never compromise on security features. Azure Synapse Analytics is the industry leader in security. So for the next sections on the serverless model, I'm going to go ahead and hand it back over to Sean. Thanks for having me, Sean. Really enjoyed talking about Synapse Analytics.
Thanks, Spencer. Really appreciate you jumping in to the first half of this. Well, but a little more than half at this point. You covered everything really really well. So I'll pick up with the serverless components of Azure Synapse Analytics. Give us a moment to swap our screen shares.
Yep. Thanks everyone for tuning in.
Thank you, Spencer, and hope everything goes well the rest of your day. All right.
Thanks, Sean.
Quick poll. Can everyone see the slide?
What makes Smile Active different is that when
Okay, so should have Azure Synapse Analytics serverless. I cannot see what I'm sharing for some reason, so I'm trusting the red line means sharing. We'll move forward. All right. SQL on Demand allows for quick and dynamic exploration of semi-structured and structured data in an ad hoc workload. The interface is a familiar SQL and T-SQL, and it supports data lake file formats such as CSV, Parquet, and JSON. The serverless benefits are, generally speaking, you pay as you go. There's no explicit cluster setup nor any provisioning. The clusters are running in the background and available. They are a shared asset at that point. That interface is familiar, and you know, we already talked about the type of files that you can use for that. Synapse Studio is a web interface for you to create files that contain live code, visualizations, and narrative text. The notebooks are a good place to validate ideas and use quick experiments to get insights from your data. Notebooks are also widely used in data preparation, data visualization, machine learning, and other big data scenarios. With an Azure Synapse Studio notebook, you can get started with zero setup effort, keep your data secure with built-in enterprise security features, analyze your data across a variety of raw formats. You can process the files into more refined formats, such as Parquet, ORC, Delta Lake tables. And you can generate SQL tabular data files against the Spark and the SQL. It allows you to be productive with enhanced authoring and capabilities using built-in data visualizations. Azure Synapse Studio Notebook is a purely Spark-based solution. The code cells are executed in Spark pools remotely. The Spark Job Process Indicator is provided to you with a real-time progress bar, which appears to help you understand the job execution status. The number of tasks per each job or stage help you identify the parallelization level of your Spark job. You can also drill deeper into the Spark UI of a specific job or stage via selecting that link on the job or stage name. And we'll do some of this in the hands-on lab. You'll actually go look at the stages of the job and look at the replayability and the runtime of it, so you can get a better job at where it optimizes it. The Azure Synapse pipelines orchestrate data movements and transformations. As Spencer said, effectively, they're the embedded Azure Data Factory in a new Studio experience that helps integrate with the other features and options. Those pre-built connectors, I believe there's 90 plus and growing, you know, monthly, accelerate that configuration and connection to a wide range of data sinks and sources, and largely you know, abstract out the effort of connecting to something that, you know, has a registered connector that's been seen before. They share many of those linked data service features with data flow and Azure Data Factory. So if you're familiar with that experience and those connectors, it will be very comfortable to you. Synapse offers low code and no code data transformations via their user interface. Again, that browser experience within the Studio ties it all together rather nicely, and you have options to be WYSIWYG GUI based, and you have options to be text and script based, depending on what your comfort and what your desires are. The data movement transformation engines are an evolution of Azure Data Factory and the data flow product line. So you'll see both of those converging in this platform. Synapse data flow capabilities are, as I mentioned, almost identical to Azure Data Factory. In fact, so similar that they share documentation. There are a couple of key differences. In Synapse, you can monitor Spark jobs where you can't in ADF. Synapse data flows will also not support lift and shift for SSIS packages because those use a separate, VM engine for their compute stage. Synapse also does not yet, last time I looked, connect to Snowflake as a sink, as a source, yes, but not a sink. Otherwise, in general, the data flow features from ADF translate really well to Synapse, providing a rich tapestry of reusable patterns and templates. Okay, I'll break for questions for a moment there. Again, it's just more refinement on the overview of Synapse. The labs will let you kick the tires and poke the buttons, and there's a walkthrough that you can do that's self-guided that leads you through the process. But it helps to have the vocabulary and know roughly what the features are supposed to accomplish. If not, we'll jump into some insights via Power BI and Synapse. So if you think about where your organization is on this difficulty and value curve, you can see an increase in the value on the x-axis and the increase in the difficulty that's linear and commensurate. We see that there's this direct relationship. In the beginning, we're looking at descriptive analytics, what happened. As we move up, it's more difficult, but we even have more value that says, why did it happen? We're moving from descriptive to diagnostic. And then the goal that everyone's shooting for now is being able to predict the future, what will happen. And that's informed, generally speaking, by what happened in the past and what led up to it. And then prescriptive is currently the highest order of value, and coincidentally difficulty prescribing what do we want to do to avoid what we think will happen, or what do we think is the best path to take forward given a new condition is going to occur. So within BI, the beginning is maximizing that value of that descriptive data. And this is where you're going to see Power BI. So Microsoft is busy bringing these things together. You've seen descriptives in some environments. You've seen predictives in other environments. You've seen prescriptive in yet third or fourth environments. One of the points of the Synapse is to bring that all together into that single unified service. And both Power BI and Synapse natively integrate with Azure Machine Learning, giving your developers a platform for collaboration and driving more business value. Azure Synapse lies at the center of that, bringing all data professionals together so they can achieve more and accelerate the time to insight. A powerful analytics platform on Azure brings frictionless collaboration for business analysts using Power BI, data pros using Azure Synapse, and data scientists with Azure Machine Learning. Only with Azure can you provide insights for all across your entire organization in near real time. One of the benefits we're seeing is the ability to take a team approach. We can put analysts on Power BI, we can put data engineers in Synapse, and we can put data scientists in machine learning, all working together in the same space. And they're not independently running, each in their own silos, and they depend on each other to do the things that they do best and don't have to carry the entire workload by themselves. They focus on the piece that they're highly skilled and have depth at. Power BI and Azure Data Services unlock big data in a way that would otherwise be impossible. As we previously mentioned, it's not uncommon for companies today to have petabytes of data across their organization. Analyzing and extracting insights from such massive amounts of data used to take hours, if not days. With Power BI and Azure Synapse Analytics, using direct query, you can take advantage of the Synapse industry-leading performance directly from within Power BI and not experience any limits on concurrency. The new aggregations feature in Power BI boosts performance even further by caching data at that aggregate level, enabling instant response times on petabyte scale data sets with trillions of rows. If the user happens to drill down to the detailed level, Power BI will submit a direct query invoking Synapse, lightning fast query performance, which is up to 14 times faster than other cloud providers. And since faster is a function of cost, it can be up to 95% cheaper too, according to that GigaHome study that Spencer referenced. Together, Power BI and Azure Synapse give users the performance they need to do modern data analytics. Forrester recently came out with a report that referenced there's a much higher ROI by moving into the Synapse space with the ability to increase customer satisfaction, get faster time to insights, and significantly lower the total cost to ownership. So I can provide you a link to the Forrester study if you're looking at selling the ROI of an Azure Synapse project. And at some point, Lindsay will be sending out some links where we will invite you to ask us more questions, including how can we help you do things like build a workshop together to explore the use of some of these platforms in your environment. Happy to share the links through that experience. VI is more than just reporting and dashboards. It enables interactive data exploration, self-service analytics, predictive analytics, and machine learning. You can even dabble in the prescriptives. So one of the labs we'll do is to build and view and publish reports in the Power BI workspace. The last one we ran, there are some connection issues, but we'll work our way through that if that's the case. We're moving the slides pretty quickly, so I'm trying to get you to the spot where we can run labs. As I mentioned, there's a program by Microsoft called the DPI 30. It's a data platform in 30 days. And as a partner, we've begun helping customers that are interested in taking advantage of Microsoft's incentives to move forward their modern data state. The key agenda in this 30-day rapid jumpstart is to analyze and design in a workshop mode, and then deploy some landing zone elements underpinned with those Azure data services that we've expressed before, and then actively transition some customer data to that platform. And then we develop key scenarios and do some service architecture recommendations. We can extend some cost consumption estimates, and then at the end of it, there's a fully provisioned landing zone that has the Azure data sources defined to support those. So think of it as an extended hands-on lab on the customer data, on the customer subscription, that allows you to move forward from the starting blocks into loaded data that is being used to deliver analytics in a rapid 30-day start. So please reach out. Here's some information. Lindsay will follow up with some questionnaires and slides later. We'll also be able to distribute a PDF of this, overview if you like. But we invite you to connect with us. We're going to take a break here for a bit, and then we're going to kick off into the hands-on labs. We're running a little ahead of what our normal schedule is. Part of it was Spencer wanted to get through as many of the slides as possible before he had to break out. So with that, what time are we at? We're at 10:13. Let's take a, we'll make it a 17-minute break so we can come back at the half hour. And hopefully at that point, we can kick off into the lab process a little bit early. One of the things about the labs is as you start your VM, there will be a timer. And the timer has a countdown, if I remember, of about 4 hours. So it's important when we start the labs that you don't plan on taking too large of a break in the middle of them, or you may not be able to get to the end. As we get the lab started, I'll poll the room and ask how you'd like to handle it. Typically speaking, if we're all in the same physical room, each person can run their lab independently, and I can walk around and help people when they get stuck or blocked. That's much harder to do in a virtual environment. And what I found typically is that I can simply share one of my screens and I would do a walkthrough of the labs. However, there's no need for you to follow the walkthrough if you would rather run at your own speed. The PDFs are pretty self-evident and clear to follow. And then if there's an issue, jump back into my walkthroughs or ask a question in the chat, and hopefully I can move forward or backward in the walkthrough to deal with the question that you have. So with that, let's take a 16-minute break. I've used a minute of the break where I will see if we can get Lindsay to hand out the secret codes to the labs, and we'll come back and see if we can set that up and get those started. There are 4 labs. It has taken me 2 hours to get from the front to the back of all 4 labs, if everything goes well. If there are some surprises or gotchas, sometimes that can add a 3rd hour. Generally doesn't take all 4 unless something happened that takes some significant debugging. I'll see you in about 15 minutes. Thanks.